Okay, so here we go with 6.5a, long division of polynomials. We finished the factoring yesterday. I did post that video in the School Loop locker. So if you log into School Loop and you click on the actual title of our course, so if you click where it says Integrated Math 3, click on that name, it should take you to a place where you can find the locker for the class. And if you'd like to rewatch yesterday's video, you're welcome to do so. I will do the same with this video. I think I've figured out how to put the notes on here so I can actually write directly on them, so hopefully that's a little bit more helpful for you. So we're going to start off by dividing a polynomial by a monomial. We learned the first day that a polynomial is something with many terms, and a monomial is something that only has one term. So here's our polynomial, and they're using the division sign just like that, and then here's my monomial, so that's what I'm dividing. Now, whenever we're dividing by a monomial, it's actually really simple. All we do is we take that polynomial, let me erase some of those lines, and we're just going to put each one of them on the top of a fraction and write that monomial on the bottom of all of them. So 2x, 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 and 2x. That's from right there, okay? So I don't worry about that anymore because this fraction bar means division, and I'm just going to divide each of them individually. Now, how do I divide each of them individually? Well, I basically reduce. So if I look at my first fraction, 10x to the third over 2x. Well, 10 over 2 reduces to 5, and x to the third over x would reduce to x to the second. If you remember your exponent rules, you do the top exponent minus the bottom exponent being 1. Another way to think about it is x to the third is 3x's on top. X on the bottom is 1 on the bottom. Cancel out your ones that match, and you're left with x squared. My next term, 12x squared divided by 2x. 12 divided by 2 is 6, and x squared divided by x would be x. So 6x is my answer there. Next one, my x's would cancel, and I'm left with 3 over 2. That's fine to have a fraction there. And then finally, 4 over 2x. Well, the x isn't going to cancel because there's not one on the top to cancel with, but 4 over 2 can reduce to 2 over 1. So I have 2 over 1x, which we would call 2 over x. So I know I have my writing kind of squishy in there, but that would be my answer when I'm dividing by a monomial. Monomials are the easy ones to divide by. Okay? All right, now we're going to talk about dividing polynomials by polynomials. So no more monomials, we've got a bunch of polynomials. And we're going to use a method called long division. Now, yes, we will learn a shorter way. However, on your quiz and on your test, you will need to know both ways. There will be certain parts that say use long division and certain parts that use the other kind of division that we'll talk about tomorrow. Now, long division is not called long division because it takes a long time. It's called long division because it takes a lot of paper. If you know what you're doing, it really doesn't take very long. So what I'm going to start off with is I'm going to go back to a good old third grade problem here with 277 divided by 12. They could write the problem this way, or they could write the problem that way. Both of those mean division. Either way, both of those signify that the 12 is what's going outside your little division house, and the 277 is what's going inside. So let's go back to how we solve this. The first thing you would do is you take 12, and you know that, sorry, my phone's going off here. You take the 12 and see how many times does 12 go into 27, or in other words, 12 times what gets you as close as possible to 27? Well, that would be 2, because 2 times 12 is 24. After that, what would we do? Most of you will say we would subtract. I would like to say that we're changing the sign. We're changing this positive 24 to a negative 24. It's the same thing as subtracting, right? That gets us 3, and then we would bring down the 7, and we would start over again. It's like we've done one cycle there. So let's see. 12 times what gets me as close as possible to 37? That would be 3. Then we take the 3 and we multiply it. 3 times 12 is 36. We would subtract or change the sign. That gives me a 1. Now, when you were in 3rd grade, you would write your answer like this. You would say 23, remainder 1. Then when you got a little further, you would do 23 and 1/12. Why 1/12? Because 1/12 is what's left over. We're going to talk about it in that form. Some of you may have gone further to where you would add a decimal and a 0 and bring that guy down, but we're not going to go there. We're just going to start with, or go to the 1/12, so we'll just ignore that guy right there. Okay? All right, so now let's apply this to polynomials. All right, so moving over here. Our problem, again, it could be written that way using the division symbol, or it could be written as a fraction using the division symbol. Either way means the same thing, and either way means that the x plus 2 is what's going to go on the outside of my little division house. So, we're going to do the method the exact same way as we did the problem to the left. Now, since I have both an x and a 2 outside, I'm really going to focus on this x. The 2 will come into play a little bit, but not as much as the x's. So my first question is, I'm looking at this x, and I'm looking at the first term in here. What do I have to multiply this x by in order to get x to the 3rd? Well, if I need to multiply x by something in order to get x to the 3rd, I have to multiply it by x to the 2nd. Now, why did I write x to the 2nd all the way over there instead of in the front of my division house? Well, I like to keep things lined up, and if you notice, I wrote it directly above another x to the 2nd. What's nice about these is you can keep things lined up, and all of your x to the 2nds will end up in a line. All of your x to the 3rds will end up with a line. All of your x's will end up, and if we can keep it organized like that, that makes it easier. Okay? All right, so once we came up with that number to write on top, just like we did over here, we took the 2 and we multiplied it by the 12. So I'm going to take that x squared and I'm going to multiply it. Now here's where that other part comes in. I'm not just multiplying it by the x, I actually have to distribute it to both the x and the 2. So x squared times x is x to the 3rd, and x squared times 2 is 2x squared. Hopefully we're okay there. So I just distributed it. That's the part that this second term, the 2 right here, plays. So what did we do then? We got our 24 and we subtracted, or I called it a different thing. I said we changed the signs. So I'm actually going to come in here, my x to the 3rd, I'm going to make a negative x to the 3rd. And my positive 2x squared, I'm going to make a negative 2x squared. That is an incredibly important step, because that step gets us to cancel there. And right here I have positive 7x squared minus 2x squared, and that's going to give me positive 5x squared. We're done with the first cycle. Now we got to bring something down. What are we going to bring down? The next term, which is positive 3x. And now we're going to repeat. So I looked at this x right here and the x to the 3rd. Now I'm going to look at this x with 5x squared. Pretend that's the first term. So x times what gives me 5x squared? 5x. Do you notice all of my x's are lined up? That's a good thing. All right, so now what do I do with this 5x? I'm going to distribute it over here. So 5x times x is, let me get rid of that guy. 5x times x is 5x squared, and 5x times 2 is 10x. Now comes my important step of changing the sign. So this 5x squared is going to become a negative 5x squared. My positive 10x is going to become a negative 10x. Okay, so now I'm just going to add them together. Those two should cancel all the time. The first one should cancel. Positive 3x and negative 10x would be negative 7x. And I'm going to bring down the next term. Now, yes, this is taking a little bit for me to do this first problem, but once you figure out the pattern that you're doing and the cycle that you're doing over and over again, it does go pretty quick. Now, I think I can go a little bit further. I think I can do one more. X times what gives me negative 7x? Well, that would be negative 7. Then what do I take with the negative? What do I do with the negative 7? I'm going to distribute it again. So negative 7 times x is negative 7x, and negative 7 times 2 is negative 14. Next step is the important one of changing the sign, so that's going to become a positive 7x and a positive 14. And what does that leave me with? That cancels out and I have 18. Now, can I multiply x by anything to get 18? No. As soon as my degree down here is less than my degree up here, I'm done and I'm at my remainder. So 18 is actually my remainder. So how am I going to write my answer? My answer involves all that. So I have x squared plus 5x minus 7. And then this remainder, since it's a positive 18, I would write plus 18 over what? We were dividing by x plus 2. And that's my answer right there. Okay, so those are a little funky, but we will practice that some more. In fact, I'll do a few more examples here. Really quick, the remainder theorem. Might use this here and there. If a polynomial is divided by something in the nice form x minus k, such as this one that we just did, x plus 2 would also be known as x minus negative 2. If I wanted to find the remainder only, so if I wanted to find that 18 for some reason, nothing else, just the 18, then all I would have to do is take that right there, the x plus 2. If I set x plus 2 equal to 0, what do I get as an answer? Well, I'd have to, let's see, I would have to subtract 2, and you get x equals negative 2. If you plug in negative 2 into that original polynomial here, x to the third plus 7x squared plus 3x plus 4, that's this, x to the third plus 7x squared plus 3x plus 4, just plugging in the negative 2. Let's see what you get. It should give you your remainder, which we know the remainder to be 18. So let's see, negative 2 to the third would be negative 8. Here I have to follow PEMDAS, so negative 2 squared is positive 4 times 7 is 28. Negative 6, 3 times negative 2 is negative 6 plus 4. So negative 8 plus 28 is 20. Minus 6 is 14, plus 4 is 18. I did get that remainder. Why is that important? Well, we'll see in a couple days that sometimes you only want the remainder. You don't care about the rest of the stuff. You just want to know about the remainder. So we'll see how that goes in a couple days. All right, let's move on. Next part of my notes. They're defining two things. They're saying g of x and h of x. Now, you're probably familiar with the notation that says f of x, like this, f parentheses x. They just use different letters to show that they are different equations. We'll talk more about that in a few days. But here's what they're asking me to do. Find g of x divided by h of x. So the top one divided by the bottom one. Now, the problem, thankfully, is already set up here, but if you'll notice, there's a term set up here that was not in the original problem. Now, when we wrote these in standard form, you have x to the fourth, x to the third. There is no x squared term. This would be x to the first, and this technically is x to the 0, but we don't worry about that. So what happens is, if you are missing a term, you gotta fill that in with a 0. That's like a placeholder. Remember when we went back on the other page and I told you how everything was going to be all lined up nicely, how your x squareds were all going to be lined up, your x's were going to all be lined up? Well, if there's no x squared, I still have to leave a placeholder because there's going to be other x squareds in the problem as I'm doing the long division. So whenever you are missing a term, you must fill in that 0. Whoops. Okay. So let me go through this one now. This one's a little bit different because it has 3 terms up front. That doesn't change anything except the distributing step. The distributing step, I'm going to have to distribute 3 things through. So, starting off, x squared times what gives me 3x to the fourth? Well, first off, I know it has to be a 3. And then to get from x squared to x to the fourth, it's going to have to be an x squared. So right off the bat, I need that x squared column. So good thing I put that placeholder. What do I do with the 3x squared now? I'm going to distribute it. Distribute it to the x squared, the negative 3x, and the 5. So 3x squared times x squared is 3x to the 4th. 3x squared times negative 3x is negative 9x to the 3rd. If I'm ever wondering what the exponent is, look at the column. If you have everything lined up, it should tell you what your exponent should be. And then finally, 3x squared times 5 would be 15x squared. What do I do next? Most important step, change the signs. This will become a negative, this will become a positive, and this positive 15x will also become a negative. First terms cancel out, and let's see, negative 5x to the 3rd plus 9x to the 3rd is positive 4x to the 3rd. And 0x squared minus 15x squared would be negative 15x squared. Notice the 0 isn't a problem anymore. We've taken care of it. Now I'm going to bring down my 4x. Cycle 1 is done. Now let's repeat the process. X squared times what gives me 4x to the 3rd? Well, that would be 4x. Again, if I'm unsure about the exponent, look at what column you're in. That should be a hint for the exponent. So now I'm going to take that 4x, and I'm going to distribute through all three of those terms. So 4x times x squared is 4x to the 3rd. 4x times negative 3x is negative 12x squared. And then 4x times 5 would be 20x. Again, next important step, change the signs. That becomes a negative, a positive, a negative. And then we just add our like terms here. Those two will cancel. Negative 15x squared and positive 12x squared gives me negative 3x squared. 4x and negative 20x gives me negative 16x. And I'm going to bring down that last term. I think I can do one more cycle. Yep. All right, x squared times what gives me negative 3x squared? That would be negative 3. So now I'm going to take the negative 3 and distribute it. So negative 3 times x squared is negative 3x squared. Negative 3 times negative 3x is positive 9x. And negative 3 times positive 5 is negative 15. Now I'm going to go back and change the signs. Now some people ask me, can I go ahead and change the signs as I'm doing that multiplication step? The answer is yes, but I wouldn't recommend it because it's nice to see what the original signs were before you change them. You notice I'm not technically erasing the other signs. I'm just writing over them in a different color. Because if I made a mistake, it's good to go back and see what I've got going on there. Okay, so let's see. Those cross out. I have negative 25x and then plus 9. So, can I go any further? No, because this was x squared. The degree here is smaller than x squared, so I'm stuck. My remainder is this whole ugly thing. So how am I going to write my answer? Well, I know that my answer is going to start off as 3x squared plus 4x minus 3. I got that from up here. And then the remainder, whenever you have a remainder that is multiple terms, polynomial, what I want you to do is I want you to put a plus, and then you're going to write that remainder over your original part of the problem. So x to the 3rd minus 3x plus 5. So you really have this big ugly fraction at the end. 3x to the 4th plus 5x minus 3 plus this ugly thing that says negative 25x plus 9 over x squared minus 3x plus 5. Okay, so that one's pretty ugly. Let's try the next one. Next one's a little different because it's the first one that has a coefficient out there. So let's deal with that coefficient. We've got everything all set up for us, so that's helpful. Don't have any zeros to worry about filling in a blank spot like we did on the previous one, so let's just go ahead and get started. 2a times what gives me 6a to the third? Well, 2 times 3 would give me 6, and a times a squared gives me a to the third. Now I take that guy and I distribute. So 3a squared times 2a is 6a cubed. And then 3a squared times negative 3 is negative 9a squared. Important step, change your signs. That's going to become negative, that's going to become positive. So those cancel. Negative 23a plus 9a would be negative 14a squared, I believe. Yep. And now I bring down my next term, plus 29a. Cycle 1 is done. Let's repeat the process. 2a times what gives me negative 14a squared? That would be negative 7a. Now I take the negative 7a and distribute it through all those. Negative 7a times 2a is negative 14a squared. And negative 7a times negative 3 would be positive 21a. Go in and change my signs. That becomes a positive, that becomes a negative. And then adding together those two cancel. I have 8a left here. Bring down my last term. And I think I have one more cycle I can do, because my degree isn't less yet. It's equal to, and I can still work with equal to. So 2a times what gives me 8a? Well, that'd be 4. Take my 4 and distribute it. 4 times 2a is 8a. 4 times negative 3 is negative 12. Change my signs. Hopefully you're noticing something here. When I change those signs, what happens? They both cancel out. What does that mean? It means I have a remainder of 0. That means it goes in nicely. I'm going to throw another word out there. That means that this is a factor of that. Okay. We'll talk more about that later. So my answer here would just be 3a squared minus 7a plus 4. With no remainder, I don't need to worry about writing anything there. Okay? All right, let's go to the next one. Next page. Let's see what we got here. The factor theorem. A polynomial has a factor if, using the remainder theorem that we talked about before, you get a remainder of 0. So you could either use the remainder theorem like we did right here at the very beginning, or you could actually go through the whole long division process and see that you have a remainder of 0. And if you get that remainder of 0, you have something called a factor. Okay? So, state if the given binomial is a factor of the polynomial. So I want to know, is this a factor? That's what I'm trying to find out. So how can I find out if it's a factor? I can divide and see if it's got a remainder of 0. Or I could use the factor theorem that I showed you on the first page. I'm going to go ahead and divide. So my h minus 3 is listed out front. Now h to the third minus 27 is what goes inside. But you notice there's this big blank spot right there. Why is there a blank spot? Well, I'm missing some terms. I need some placeholders. H to the third, I need an h squared. And I need an h to the first. But I can't, ignore what I just wrote. I can't just write h squared. I have to write 0h squared and 0h. Reason why I can't write h squared is because h squared implies that there's a 1 there, and we don't have 1h squared. We have 0h squareds. There's none of them there. If we had one, we would have seen it. So make sure you put the 0 with those. That way you've got them. And let's start our process. H times what gives me h to the third? That would be h squared. H squared times what gives me, h squared times h gives me h to the third. H squared times negative 3 gives me negative 3h squared. Let's change our signs. Negative, positive. Those guys cancel. I have 3h squared, and I'm going to bring down plus 0h. Okay, let's do the process again. H times what gives me 3h squared? That would be 3h. Sorry, my handwriting's terrible on here. Now I'm going to take my 3h and distribute. 3h times h is 3h squared. 3h times negative 3 is negative 9h. Next thing I do, change my signs. That becomes a negative, that becomes a positive. So those guys cancel. I have 9h. And I'm going to bring down my negative 27. I think I have one more round. H times what gives me 9h? That would be 9. I'm going to distribute that 9. 9 times h is 9h, and 9 times negative 3 is negative 27. Hopefully you're noticing something here. When I change my signs, what do I get as my remainder? My remainder ends up being 0. Now, this problem was not just saying divide those. If it was saying divide those two things, my answer would be h squared plus 3h plus 9. But the problem is actually saying state if the given binomial is a factor of the polynomial. So is h minus 3 a factor of h to the third minus 27? Yes, it is a factor. It is a factor. And why is it a factor? Because the remainder is 0. That's what we like to see. Now, if you want to look a little bit further into this, Mrs. Armstrong here kind of points out the fact that when we talked about our difference of cubes formula and our sum of cubes formula, we took something that was in a difference of cubes form. That's a difference of cubes form, right? And we took the h and the 3 from here, and we did h minus 3, and then you square the h, change it to plus 3h, and then plus 9. That's that formula we learned yesterday. Well, that's one of the problems from our division problem. That should be our answer, and it is. So this is actually a problem that is very related to our difference of cubes formula that we learned yesterday. All right, on to the last problem here. Okay. Now, let's see. One thing that is a little different. Okay, this one right here, our divisor on the bottom is not in standard form. So I actually want to put that in standard form. Now, you don't come across this too often, but every now and then, they do want to mess with you and give you something to kind of confuse you. So I'm going to put the negative 2x squared there and plus 1. Now, one thing that she says here is that when you change it, you don't have to fill in missing terms, because if you notice, it's missing a plain x term. You don't have to fill in a missing term if it's on the outside, because the placeholders we need are in here. We don't need a placeholder on the outside. What we're just going to have to do is we're going to have to be careful to line up terms as we multiply. And I'll show you what that looks like. Okay? So, first thing, negative 2x squared times what gives me positive 4x cubed? Well, negative 2 times negative 2 is going to give me positive 4. And x times x squared will get me x to the third. I think that's right. Positive 4x to the third. Now I'm going to take this and I'm going to distribute it. And this is the part where I have to be careful lining up things. So negative 2x times negative 2x squared is positive 4x to the third. And negative 2x times 1 is negative 2x. This is that lining up thing. I don't have a term right there. Okay? So in essence, I want to think of this as plus 0x squared. Okay? If it's easier, you can put the plus 0x squared here and just treat it like the problems we have been doing. Okay. Sorry about my stuffing nose here. All right, let's change our signs. That becomes a negative. 0, it doesn't matter if you change it positive, negative. Adding 0, subtracting 0 is the same thing. Change that guy. And what have I got? Those guys cancel. I have negative 8x squared And let's see, it looks like negative 2x and positive 2x cancels too. So I have minus 17. Not minus 7, minus 17. So again, I have a 0 in there. I'm going to go ahead and write the 0 just because I like to see placeholders. For me, it's easier to understand. All right, let's do our next round. Negative 2x squared times what gives me negative 8x squared? Well, that would be positive 4. Now I'm going to take that 4 and distribute it. I get negative 8x squared. And positive 4 times 1 is positive 4. I have 0x there, so let's see, it'll probably stay like that. And let's go ahead and change those signs. That becomes a positive. That becomes a negative. And let's see what we've got. Those guys cancel. Those guys cancel. And I'm just left with negative 21. So it looks like I have a remainder of negative 21. So my answer would be negative 2x plus 4. And then negative 21, I'm going to put, you could either write plus negative 21 over negative 2x squared plus 1, plus 1, or you could change that negative sign into a subtraction sign there. Yeah, I hesitate to say that because if your remainder is a binomial or higher, you really can't put the negative sign right there. You have to keep the negative sign there because it doesn't apply to all the terms. So just to kind of stay in a good pattern, let's go ahead and just leave it like that for now. We'll deal more with that later. Let's see. So, you could check your answer by multiplying. Take the original divisor, multiply it by your answer, and add your remainder, and you should get the original dividend up there. So let's see. Negative 2x squared times negative 2x is 4x cubed. Negative 2x squared times 4 is negative 8x squared. 1 times negative 2x is negative 2x. And 1 times 4 is 4. And then plus negative 21. Let's see what that gives us. 4x cubed minus 8x squared minus 2x minus 17. Yes, that was the original problem, so we are good. Our answer is set. Okay? All right, I hope this was helpful for you. If this is helpful, I can continue to do this. Hopefully I'm not out too much longer. I am in a fantastic cast that my kids have decorated for me. So fun times for Mrs. Franken here. But I should be back at the latest maybe next week. So good luck. Have fun dividing.